In this video, you will learn how to implement Retrieval Augmented Generation, also called as RAG, with Spring AI using Ollama and PG Vector database. We'll start off by understanding the purpose of Retrieval Augmented Generation, and then we will discuss some terminologies that are associated with the Retrieval Augmented Generation, also called as RAG. And finally, we're going to build a sample Spring Boot reference documentation assistant that can look up into Spring Boot reference documentation PDF and answer our questions. So without any further delay, let's start the video. So first, let's start off by understanding how the traditional LLM model is working. So here we have the user that is asking a question to the LLMs like OpenAI, Gemini, and Grok. So you can take this ChatGPT as one of the examples. So whenever the user asks a question to the LLM, it looks up and queries the pre-trained data of the LLM. Usually this data is historical training data and it is not up to date with the current affairs. This is one of the problem with the traditional LLMs because they rely on historical training data and not up to date with the current data. And they also have no knowledge about our own knowledge base, like our internal documentation, etc. So if you have a huge internal documentation and you want to use this and you want to use the capabilities of LLMs to get a nice summary out of your internal documentation, then it is not possible with the traditional LLM way. So that's why a new AI technique called as Retrieval Augmented Generation was introduced. So it is nothing but a technique that is used to retrieve external information like our knowledge base, like PDFs, HTML or CSV or text documents, and using that information and we combine the logical reasoning capabilities of LLM, and then we generate some accurate responses to the user questions. So let's see how this Retrieval Augmented Generation or RAG works in action. So the user first uploads their knowledge base document. So for example, this can be a PDF or text document, and then they upload this document to our application, which is enhanced with this RAG capabilities. And then the application processes this document and then stores this data in the form of vectors in a vector database. A vector database is a specialized database like SQL relational database and non-relational database that stores data in the form of vector. A vector is nothing but a mathematical representation of the human readable text. So here you can see one example. We have one word called as cat, and this is how a mathematical vector representation of this can look like. And we have different kinds of database to store this vector data. So one of them is Pinecone, Chroma, PG Vector. So we are going to use PG Vector in our sample application, and Redis. In the Spring AI documentation, if you go to the section of vector databases, you can see all the supported vector databases. So you have the MariaDB, Elasticsearch, Apache Cassandra vector stores, and we have so many options already in the vector database space. So coming back to our tutorial, to fulfill the user queries, our application will perform a similarity search based on the given question to the vector database, and then we get the response back from the database, and this response is sent as an LLM prompt to the OpenAI, to our LLMs, and then our LLMs will give back the answer. So to perform the steps 2, 3, and 4, we have something called as a data ingestion pipeline. So let's go ahead and discuss this in detail. So here we have our user document, and what actually our application will do is it takes the user document and it splits that document into different chunks, right? Different text chunks, and then it will convert these chunks into something called as an embedding. An embedding is a type of vector that is used to represent the data in a format that is understandable for LLMs. So LLMs work with the data in the form of embeddings so that they can understand and process this data. So we need to essentially convert this text of chunk into embeddings and then store it into the vector database. So that's our application is supposed to do, right? So once this data is stored in the form of the vector database, so we retrieve this embeddings and then we provide it along with the user prompt to the OpenAI to the LLMs. So that's what we are essentially doing in the steps 2, 3, and 4. So I hope this is clear to you. What are the different steps that are part of the retrieval augmented generation and what are the terminologies we use as part of the RAG techniques. So let's go ahead and now implement our Spring Boot reference documentation assistant. All right, so now I'm in the start.spring.io website, and here we are going to download the skeleton project for our Spring Boot reference document assistant. So I'm going to select the Maven project with Java and Spring Boot version as 3.4.3 because this is the latest version as of creating this video tutorial. I'm going to use packaging as jar and the Java version as Java 21. And coming to the dependencies, I'm going to first add Spring Web because we are going to expose a REST API, and then we are going to make use of Ollama support through Spring AI, and the next thing we are going to add is PG vector database followed by the Tika document reader. So this we are using this dependency to be able to process and parse the PDF documents. So the Apache Tika document reader is not only used for PDF documents, but it can be used for various kinds of document formats such as PDF, Word files, PPT, and HTML. So the next thing we are going to do is to also make use of Docker Compose support because we are going to use Docker Compose to start the container for PG vector database. So these are all the dependencies we need to get started with our application. So let's go ahead and click on the generate button. So this will download the sample project to your machine, and then I'm going to open this project in my favorite IDE IntelliJ, and then we can get started with the coding part. And as we are using a local LLM, we need to download also the Ollama from the Ollama website, ollama.com, and if you just click on download, you can download the Ollama variant based on your operating system. I already have this installed on my machine, so I'm not going to do it right now. So if you're not aware of what is Ollama, it's software where you can run local large language models like Llama 3.3, DeepSeek R1, Mistal, Gamma 3, and any other models. So I've opened the sample application in IDE. So before going ahead and starting coding, you have to make sure that after you install Ollama, make sure that it is up and running because we will be interacting with its local REST API. So that is exposed on port 11434. So having said that, let's go ahead and create our first bit of code. So the first thing I'm going to do is open the pom.xml file just to go through the dependencies we have. So we have our Spring Boot Starter web dependencies that is going to add the REST API capabilities. We have our Spring AI Ollama Spring Boot Starter. So that is going to add all the auto configurations that needs to be configure all the auto configurations related to Ollama. And we have also the Spring Boot Starter for the PG vector store database. And finally, we have the Spring AI Tika document reader that's going to also provide us the functionality to process the documentation using Apache Tika. And finally, we also have the Spring Boot Docker Compose dependencies. So we are going to make use of it shortly. So the next thing we are going to do is open the compose.yaml file. And here you can see that the Docker Compose file already contains this Ollama image. That's actually good because I didn't. That's actually good. So you can just run, if you don't want to install Ollama directly from the website, you can make use of this service to run Ollama on port 11434. Because as I already have this installed on my machine, I'm just going to remove this particular part. And we're just going to make use of this PG vector service. So here we are providing some environment variables like PostgreSDB as my database. So instead of my database, I'm going to change this as vector.db, and the secret is going to be test password, and the user is going to be test user. So if you're wondering why we have PostgreSDB as an environment variable, because PG vector is a variant of a Postgres database, right? So it's just like an extension on top of Postgres database. That's why it's called as PG vector, and we are going to make use of the same environment variables as the Postgres database. The next thing I'm going to do is open the application.properties file, and I'm going to add some configuration here. So the first configuration is going to be about Ollama, and I'm going to type in here spring.ai ollama.base URL is going to be http localhost 11434. It's going to be the default URL because as Ollama will be running on this port. And the next thing is going to be springai.ollama init.pull model strategy, and we are going to use the model strategy as one when missing. So what this particular property will do is it will try to pull the particular large language model we are using. So if it is not existing on your machine, it will try to download it whenever this model is missing. We are going to provide also a timeout. So with the help of Spring AI, init.timeout as 5 minutes. So I'm just going to provide the default value 5 minutes. If you want, you can also provide it as 1 minute. I'm just going to leave this as a default as 5 minutes. And now we are also going to mention what is the large language model we want to download. So for that, I'm going to type in spring.ai.ollama.chat.options.model. And here we are going to provide the default value Mistal, right? So you are going to make use of the Mistal LLM model. And finally, we are going to add the property spring.ai.vectorstore.pgvector.initialize schema. It's going to be true. So we're going to add this property to initialize the PG vector schema automatically for us. So this will enable the vector database functionality also in our application. Lastly, we need to provide the Spring data source URL for PG vector database. So for that, I'm going to type in spring.datasource.url. It's going to be JDBC, PostgreSQL, localhost 5432, and the name of the database we have defined inside the Docker Compose file. So that's going to be a vector database. So I'm going to go back and I'm going to add also the data source.username is going to be test user, and spring.datasource.password is going to be test password. So once this is done, we are free to start the application and see if it's able to start up or not. So I'm just going to open the main application class and I'm going to run this in debug mode. And you have to notice that once the first time it's running, it will try to download the PG vector image from the Docker Hub. So it may take some time to start up the application. And once the image is downloaded and it starts to run the Docker container, the next thing it will do is it will try to download the Mistal image from the Ollama repository. So it may take some time in the first when you're running this application for the first time, it may take some time to initialize this application. So once this is done, you can see that the application is able to start without any errors on the port 8080. So for me, it took 5 seconds to run the application. On your machine, based on your configuration, it may take more time. So once this is done, we have to copy the actual PDF file. So for that, I'm going to create a new folder in the resources package. In the resources folder, I'm going to create a new directory called as PDF. And in here, we need to add our Spring Boot reference documentation PDF. So for that, I'm going to open the web browser and I'm going to search for Spring Boot reference documentation PDF. And this is the first result that is going to pop up. So I'm going to click on this link. I think to find out if you have a latest documentation or not, you can just refer to the version number in the URL. And here you can see that this is for version 2.4.3. So maybe I can type in 3.2.7 and it will redirect me to the latest version or to a relatively latest version of the Spring Boot documentation 3.2.7. So you can go ahead and download this particular PDF and you can add it to the PDF folder of our application. So after adding this reference documentation under the PDF folder, I'm going to go ahead and implement the document ingestion pipeline we saw before. So for that, I'm going to create a class under the root package. I'm going to right click and create a class called as document ingestion service. And I'm going to add it in a package called as ingestion. This will make sure to create this class under the ingestion package, and I'm going to add the service annotation on top of this class, and this class is going to implement a command line runner because I want this class to be executed at the time of startup of the application. So this is one way of running some logic during the application startup. So as I'm implementing the command line runner interface, I'm going to have to implement this method, the run method. So inside this run method, I'm going to read the PDF and then split the PDF contents into chunks, and then finally store the data in the vector database. So these are the 3 steps we are going to perform. So to read the PDF contents, to read the PDF contents, I'm going to make use of the Tika document reader. So for that, I'm going to create an object of Tika document reader Tika document reader, and to this document reader I have to pass in the actual document, right? So to be able to do that, I need to first inject the resource, the Spring Boot reference documentation, the PDF resource into the class. I'm going to first reference the class path, and I'm going to provide the location of the document here. So that's going to be under the resources folder, and under the resources folder we have the PDF folder, and finally we have our Spring Boot reference.pdf file, right? And I'm going to store this under the resource object. So it's going to be resource interface from springframework.co.io, and I'm going to name this as resource. So I'm going to copy this resource variable, and I'm going to pass in as a constructor argument to the Tika document reader object. So once the document is supplied to this Tika document reader, I need to split the PDF contents into chunks, right? So for that, I need to make use of the text splitter interface from Spring AI transformer.splitter package. So I'm going to call this as text splitter, and this text splitter is going to be of type token text splitter. And after defining the text splitter, I'm going to split this this document into multiple chunks. So I can do that by typing text splitter dot split, and the split method takes in a list of documents. So if I just go inside this method, you can see that it is going to take a list of documents as a method argument. So for that, what I can do is I can make use of the Tika document reader variable, and I can call the read method. So that's going to return a list of documents. So this text splitter is going to split this document into multiple text. So let's store this in a local variable called as documents. And now we have these documents, and we can store these documents inside the vector database. To do that, I can type in vector store. So to do that, first we need access to the vector store. I'm going to auto-wire this vector store inside the class. So this is going to be vector store interface from Spring Framework AI.vector store package. So let me quickly auto-wire this by adding the constructor parameter. And now I can take this vector store variable, and I can type vector store dot accept, and here we are going to accept list of documents. Right, so I'm going to accept the documents. So what this vector store will do is it will convert this list of documents into embeddings and then store it inside the vector database. If you go inside this vector store interface, you can see that we have multiple implementations here. So one of them is PG vector store, simple vector store. As we have the auto configuration already set up for us, so the Spring Boot is automatically going to pick up the PG vector store for us and store the documents. So once this is done, we can restart our application, and So I'm going to rerun the application, and so for the first time you're running this application, it may take some time to it takes some time for our application to read this PDF and split it into multiple chunks and then store it into the vector store, right? So you can see that we have some logs coming in from the text splitter. It's trying to splitting up the document into 549 chunks. It is trying to then store it inside the vector store. So to make sure that this information is correctly stored inside the database or not, we can try to connect to this PG vector database. I'm using Ultimate Edition of IntelliJ, so that's why I can directly make use of the database tab inside the IDE itself. If you're not using this, you can of course use any other PG vector database UI. So I'm going to connect to the data source of PostgreSQL, and here I'm going to provide the name as Postgres localhost. The user is going to be test user, the password is test password, and the database is going to be vector DB. I'm going to test the connection, and hopefully the connection test is succeeded. So I can go ahead and apply and click on OK. And if I expand this vector DB, under the public schema, if I go to tables, you can see the vector store table that is automatically created for us. And if you see here, we have multiple columns inside this database. We have this ID, content, metadata, and embedding columns. So here you can see the content, which is in human readable text, and we also have some metadata about this text, which is the source PDF. And finally, we also have the embeddings, right? So here you can see the actual text, how this human looking text is converted into a mathematical representation called as embedding. So it's very similar to the example I showed before in the presentation. So this is how the data is stored inside the PG vector database. So now we have the data inside the vector database. So the next step we are going to do is to create an endpoint where we can chat with this data. So let's go ahead and do that. Under the root package, I'm going to create a new class called as chat controller. And I'm going to do this under a package called as control. This is going to add this chat controller into my local Git repository. As this is a REST controller, I'm going to add the REST controller annotation, and I'm going to expose this controller under the mapping /API/chat, and I'm going to expose a post endpoint here. So for that, I'm going to add a post mapping. The name of this method is going to be public string chat, and the request body is going to be a incoming message from the user. So inside this method, we are going to make use of the chat client class from Spring AI. So for that, I'm going to type in chat client dot builder, and in here we need to, inside the builder method, we need to provide a chat model class, right? So if I go inside this chat model interface, if I click on all the implementations, you can see that we have the Ollama chat model, because as we have the Spring AI Ollama Spring Boot starter, it is auto-configured. So this particular dependency has auto-configured the Ollama chat model class for us. So that's why it's going to pick up this Ollama chat model. So what we are going to do is we are going to inject this Ollama chat model into our controller. So I can do that by typing private final Ollama chat model, and I'm going to add the constructor parameter for this particular class. So I'm going to copy this reference variable, and I'm going to provide this to the builder method. And to build the chat model, I'm going to make use of the build method. And finally, I'm going to provide the prompt to this Ollama chat model using the prompt method. And the next thing we're going to do is define something called as an advisor, which is a component that's doing all the matching. So in this diagram, we saw that our application is supposed to fetch the data from the vector store using the by performing a similarity search based on the given question, and create an embedding and send this message as an LLM prompt with the relevant context, right? So an advisor is something that is doing this out of the box for us. So we are going to make use of a question and answer advisor from Spring Boot, so from Spring AI. So for that, I'm going to create an object of type new question answer advisor. So this question answer advisor is going to take a vector store as and per constructor argument. So for that, we need to inject the vector store object into our class. So I'm going to type in private final vector store. So this vector store interface is coming from the ai.vectorstore package, and I'm going to name it as vector store, and quickly add this to the constructor parameters. And I'm going to copy this vector store variable and pass into this question answer advisor object. And we need to also provide the user message, of course, in the user method. And here I'm going to provide the text from the user, and I'm going to I'm going to type in the method to call the response and then convert it to the user readable string. So this is this particular method call chain is doing all the magic. So it is taking the Ollama chat model as an input, and it's going to create a question answer advisor, and which is going to do a lookup inside the vector store and then send the request to the LLM as a prompt based on the message that is provided by the user. And finally, we are going to take the response back and the response from the LLM and sending it as a response back to the user. So to do that, I'm going to add a return statement. That's what we need to do to implement the assistant. So let's restart our application now. So our application is successfully restarted. So I opened Postman, and here I prepared a request to the localhost 8080/API/chat endpoint. And here I also provided the question inside the body as a text. So I'm going to ask a question, how to develop a Spring Boot application, and I'm going to click on send. And I'm running this LLM on M2 Mac Mini. So for me, it is taking around somewhere between 10 to 20 seconds to get a response back. If you are running a more powerful machine, you may get this response more quickly. Or if you're running a normal machine without any graphics card and with low memory, then you may not even get the response back, because the LLMs need some powerful. So if you need some powerful machines to run LLMs. Okay, so finally got the response in 47 seconds. Postman client was waiting 47 seconds to get this application, to get this response. And here we and here is what we got, right? So it is providing a good summarized information about how to create a Spring Boot application. So it's going to it's replying about project setup and creating a Java file, the main Spring Boot application file, adding the REST controller and Spring Boot annotation, and then how to run this application using the run commands. So here you can see that our application is intelligent enough to respond to the questions based on our knowledge base. So if you replace this Ollama with maybe Spring or with OpenAI or a Gemini models, then you may get a more accurate information, because it all depends on the kind of model that you are running to fetch the information, right? So obviously the model which I have on my local is not as powerful as OpenAI 5 or Gamma 3 or any other new model that is on market. You may observe that the response may vary drastically based on the model you are using. So that's the video. I hope you learned something with this video, and I will see you in the next part. Until then, happy coding, techies.